Hi everyone. In this video, we are going to discuss about the ninth theorem from the geometry of circles. The theorem says that the angle between a tangent and a chord drawn from the point of contact is equal to any angles subtended by the chord in the alternate segment. Let's suppose we have a circle like this having center at the point O, and also we have drawn a tangent at point A on the circle, and from the point of contact I have drawn a chord. The chord is AB, and let's suppose that this chord is making an angle alpha with the tangent at the point of contact. And then I have picked a point C on the circle on the other segment, of course, that's the alternate segment, meaning if the chord is a minor chord, then the segment that we should consider is the major segment. So in this case, the chord AB is actually a minor chord because it's less than the diameter. So I had to pick a point C on the alternate segment, which is the major segment, and then I have shown the subtended angle, which will be angle ACB, and let's assume that the angle ACB is equal to theta degree, and then we have to prove that angle theta is equal to angle alpha. And in fact, you can draw any subtended angle on the major segment for this chord AB. All of those angles will be equal to theta, and ultimately we are going to prove that theta will be equal to alpha. Now, in order to do the proof, I have to do a little more construction. I am going to join the center with A and B. Then we have a small little triangle here, triangle OAB. If you think about this triangle, it is actually an isosceles triangle. Why? Because OA is equal to OB. It's the radius of the circle. So those two sides are of equal length. That means triangle OAB is an isosceles triangle. And since it is an isosceles triangle, think about the angle OAB and the angle OBA. They will be of equal size, and each of them will actually be 90 degree minus alpha. Now why 90 degree minus alpha? Because OA is actually perpendicular on the tangent, and then we already have an angle alpha there. So the remaining angle, which is the angle OAB, that will be equal to 90 degree minus alpha. And similarly, angle OBA will also be equal to 90 degree minus alpha. That's what I have noted in the diagram there. Due to lack of space, I have made a common note there that those two angles, the angle OAB and the angle OBA, each of them will be equal to 90 degree minus alpha. And also, what would be the angle AOB? That's the central angle. Well, that will be 2 times theta. We have already seen that in a previous theorem, that the central angle is double the size of the inscribed angle. So here the inscribed angle is theta, so the central angle will be 2 times theta. Now, if we add up all 3 interior angles of this triangle OAB, then their sum will be equal to 180 degree, because we know from the angle sum property that the sum of the interior angles of a triangle is equal to 180 degree. And then if we remove the parenthesis and do a little bit of simplification, we can say that 2 times theta plus 180 degree minus 2 times alpha will be equal to 180 degree. And from here, you see the positive 180 degree on both sides will cancel out each other, and we are going to be left with 2 times theta minus 2 times alpha equals 0. And from here, we can say then 2 times theta will be equal to 2 times alpha, and divide both sides by a positive 2. We get theta is equal to alpha. And that's exactly what we needed to prove. And this is also another interesting property of circle, so please make a note of it. I hope the proof made sense. Thank you for watching. See you in the next video.